gonna do an example on geometric sequence. Um, I mean, not really. We're gonna do a series now, but I mean, we're gonna do both at the same time, series and sequences. So yeah. So what is a series is like the number. Well, I googled it and it said, I hope Google doesn't copy strike me. I don't know what that means. Wait, isn't YouTube owned by Google? But a series is a succession, so it's a number of event, objects, or people of similar or related kind coming one after another. Uh, I guess I don't understand that, but series in maths, just kind of define them as the addition of all of those. So for of a sequence, so if we had certain amount of stuff, then we would add those. Honestly speaking, it's an operation of adding quantities. Yeah. So yeah. So we have two type of series that are dealt with in mathematics in grade 12, which is the arithmetic series and the geometric series. So I think we can start with the um, arithmetic series. So the arithmetic series is just adding those numbers, whatever they are. So if we have the most simplest form of arithmetic sequence, we know that it's arithmetic because its difference is constant throughout. It's one throughout, and if we had to add this, will be 1 plus 2 plus 3 plus blah 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 blah. This Tn is equals to Tn equals to T, so the addition will be represented by T by N equals to 1 till infinity, because they don't tell us how many numbers we are adding, and you will just have to find that, and probably use infinity because I mean it approaches infinity. So yeah, it's just that I mean sometimes they will ask for you to add numbers to a certain type of quantity. Maybe they say at the first five numbers, or at the whatever type of types of numbers. So what's important about series is you have to understand the addition stuff, the sigma, how sigma notation works. So sigma notation, let's say n to infinity, n equals to 1 of maybe m plus, I don't know, okay, m plus k. So m as something that depends on n plus k as a quantity of n. This equals to, so you can separate these into m n plus k depending on n. Secondly is the multiplication of constants. So n m equals to 1 of c times n, depending on that, would just be c times the entire series multiplied by c. Let me see if there's anything I'm cooking. We can have we can have the series of m plus n. No, let me not say n, I want to use k. N plus k. Now okay, let me not use it, let me use p and q, where p and q are not dependent on n. this is just p plus q, because these are just, it's like having a series, so these are just constant. It's like having a series n equals to 1 of 2 plus 3. This is just 5, because none of these two terms depend on n, so you can't add anything that is subjective to n. So this kind of says that if we had a series like this of m n plus q, it would just be this series n m plus q at the end. So you can solve the series of this and then add q at the end. It really doesn't matter how you do it. So yeah, so we can have examples of these. I'll have to erase you guys. You have to know, okay, let me make so if we have something like this, we can have maybe it's n squared and n. So this series will be there of n squared plus series of equals to 1 of n, which is this one. So you can add those two different series. If you had this of c, maybe this is have n squared, right? And this is like 2. It can be equals to 2 times the series n squared, like this one we've already made an example. And then it's n squared, so it will be the series of n squared plus, we said q is 3. So just that. So there is no like need to kind of stress yourself and that. Just know these rules, write them in a piece of paper and memorize them as much as possible. They're really easy, there's nothing to worry about, they're straightforward. So we're gonna do an example. Let's say that we have this and then they say add these terms until n equals to 5. We're doing the simple one. So it's 1 plus 2 plus 3 plus 4 plus 5, which equals to 15, which would be E, and it equals to 15. How do you write this in Sigma notation? So in Sigma notation, we write where our n starts, and n usually starts at 1. And we write our where n ends. Here n ends at infinity, but here n ends at 5. So this is equals to 5. And then here we write our tn. Our tn is n. So the term here is the end, the beginning, and the tn. So just think about it that way, is where n beginning, b not b, beginning, the end, and the tn. We can have multiple examples of this. Yeah, so in an arithmetic sequence is usually very straightforward in kind of like showing its beginning and its end. I think there is a formula for the arithmetic sequence. I just want to look for it because I forgot what it looks like. But there is a formula for the arithmetic sequence if you wanna get like what term is that using a certain formula. So yeah, okay, I found it. The formula is Sn equals to n over 2a plus n minus 1 d. It's probably at the back of the purge. I don't know if they could say that you should prove this formula, but let's see if we can. Let's try. Okay, let's start space. So arithmetic sequence, the first term is a, our second term is a plus d, our third term is a plus 2d. So the general formula of a what's that? arithmetic sequence Tn would be a plus n minus 1 d. So I don't know how to do this. I don't know how to do this thing. Let me see. I would be adding, right? I would be adding the successive terms of this. So it's as finding the sum to n, okay, to m, let's say to m of n equals to 1 of a plus n minus 1 d equals to, how would we do this, guys? Help me out, okay? Help me out. Okay, so we're gonna do the proof here. I'm gonna try and do a proof that is kind of different from the one that they do in matric. But yeah, I don't know, ask your teacher if you can use the proof that I'm using right now. But yeah, so I'm gonna say, okay, I have this and I want to prove this, that this is true for all n, right? So I'm gonna say, okay, the first term is a plus d, a plus 2d, and so on. So the sum of the first term has to equal to a. If we substitute that here, if we substitute 1, we're going to have 1 over 2, 2a, and then that is 0, which equals to a. So left hand side equals to the right hand side. And then I'm going to take this and I'm going to say, I assume that this is true for n equals to m, right? When I assume that is true, I'm saying the sum of m would be equal to m over 2, 2a plus m minus 1 d. So I need to prove that this is then true for m plus 1. So the sum of m plus 1 would equal to the sum of m plus a. And this is going to be sum of m plus 1 would equal to sum of m plus 1 over 2 times 2a over m plus 1 minus 1 d, right? M plus 1, I'm going to have m over 2. I'm going to have 2a plus m plus 1 minus 1. I'm going to have m minus 1 d plus 1 over 2, because you took out that term, you took out the plus 1 term, and 2a, and then you don't have any d's, which equals to 2a plus m minus 1 plus a. So I'm going to say, therefore, this is true for all m that is an element of a natural number. And then I'm going to say by induction. I don't know if you can use this proof to your teacher. Ask them if you can use this proof. But I'll do the second proof if you guys think that this one is too not funky. I know you guys will be like, oh, she's doing the easy one. Oh, she's doing the easy one. We want the hard stuff. Look at us. Okay, so here the first proof, right? It's this type of proof is that when you can write Sn as n plus d plus n plus 2d plus da, 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 plus the last term will be n plus, so the last term will n minus 1 d. And you can still write this as a plus n minus 1 d plus a plus n minus 2d. So if you're going from like the last term to the first term, you're gonna write it like that, right? And then you're gonna write it like that plus da 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 plus until you get to a. So if you add these two equations right here, you're gonna have Sn to Sn because you added this one and this one. It's gonna be the a plus a is gonna be 2a, and then a plus, wait, this is 2a plus n minus 1 d, plus when you add this one with this one, you're gonna get 2a plus n minus 1 d, and you're gonna get literally the same thing because even this last term will be 2a